Now let's talk about solving an equation with a radical. This one has a radical in it. There's the radical right there. That's square root simple. Now, the first thing you need to do is isolate your radical. Luckily, number 15 from my homework is isolated already. So the square root of 5x plus 99 doesn't have anything on that side except for that chunk, that radical chunk right there. So when I have something like a radical isolate is equal to other stuff, then I'm going to square both sides because that makes the radical disappear. And when I square both sides over here, then I'm going to have a perfect square trinomial. This one just stays 5x plus 99, and that's equal to, and remember how we square a perfect square trinomial, we have the first term squared, that's 4x squared. Leave some room, 22 squared would be 484. And then to get your middle term, you multiply these two together, you get 44, and then double that, so 88. So plus 88x. So I have 5x plus 99 is equal to 4x squared plus 88x plus 484. Now this thing's quadratic. You can see right here I have an x squared term, which means it's quadratic. That tells us that we need to set it equal to 0. Now my quadratic will have a positive coefficient on the right hand side, so let's move everything over to the right hand side. I'm going to subtract 5x from my other linear term, and I'm going to subtract 99 from my constant term. So 0 is equal to 4x squared plus 83, and then plus 385. So let's see here. Now we want to factor this. And I know I'm not going to want to have 2 and 2 right here. Just a little review of factoring. I know I can't use 2 and 2 because that means when I multiply my outside and I multiply my inside, then I'm going to end up with an even number and an even number. But they have to add together to give an 83. I forgot my x. An 83x. So since I know that they're going to add to an odd, I can't make sure that I have an even and an even. So I can't use 2x and 2x's, and I'd have two evens, and I can't get an odd that way. So I'm going to have to use 4x and x. Now this one is kind of a big booger, but we can see something cool here. See, 3 and 5, if you add them together, then you get that middle term, which is an 8. So that means that it's some sort of multiple of 11. Whenever you have a 3-digit number and the two outside numbers add to give the middle one, it's some sort of multiple of 11. So let's see here. We know it's a multiple of 5, so this would be 5 times 7 times 11. Okay, now let's try something here. Let's put a 7 in right there. That means that my other terms would be 55. I think that'll give me what I need. Now I have a plus and a plus. Since this is a positive, I know I have two of the same thing. And because this is a positive, I know that I have at least one positive. If they're the same and one of them's positive, well, I have two positives. So let's just check it out to make sure. I multiply these and I get a 28x. I multiply these and I get a 55x. Add them up and you get an 83x. That's good. So that means that we picked the right factors. Now I need to set each of these equal to 0. If this one's equal to 0, I get negative 55 over 4, and the other one is negative 7. Now, they didn't have us do any homework with the domain restrictions in the radicals, but we know that we're not allowed to have a negative under a radical. That's going to cause some problems because if one of these answers should have produced a negative, we would have squared it out. When you square that negative, it's going to turn it into a positive. So possibly one of these will not work. Let's try it out. And through the magic of technology, here is all the arithmetic worked out for you in the check. So if you plug in the negative 55 over 4, then you end up with an 11 over 5 is equal to a negative 11 over 5. Why don't you try that in a calculator and make sure that you're hitting all the right buttons and getting to the same place I am. Now, this is not true. 11 over 5 is not equal to negative 11 over 5, which means that when we checked it, we got a false. That is, so this negative 55 over 4 is not good. Now, then we checked the negative 7. You plug it in here, and you get a negative 35 plus 99. That's a 64 under the square root. Over here, you get a negative 14 plus 22. You end up with the square root of 64 is equal to 8. And yes, in fact, the square root of 64 is 8. What this tells us is that we got two solutions, but only one of them worked. The reason why goes back to the idea of domain restrictions, but we are taught to check these radicals. The only solution is negative 7.